Greetings. My name is presentation2023. I will be doing a report. Presentation2023 with student number 16261763. I declare that this is my own work. So I have been tasked as a civil engineering technologist. I have been tasked by the municipality of Tsepiso local municipality to design a water system that will provide water for four different townships. It is very important that this project be done correctly because these communities might be experiencing power shortages, water shortages and outages. So this will benefit the community very well. And since it is a known fact that in South Africa we are going through some sort of a drought, it is very paramount that these type of projects are done and are done well with the type of maintenance they require. So the community that I was tasked to provide with a water system is the Tsepise local municipality. There I'm supposed to provide for 4 different townships, as you can see in this overview of the design. There's township 1, there's township 2, there's township 3, there's township 4, and the water will be supplied from the Nyangwe River, and we will be using the abstraction works as the datum. So all of the levels which have been given in this overall layout will minus that level to get us the reduced level. We are also given by the WSPD the average daily demands of the communities. So for township 1, we know that it demands 65 liters per second. For township 2, it demands 70 liters per second. For township 3, it demands 80 liters per second. And for township 4, it demands 140 liters per second. I am expected by the municipality to carry out the following: the number of pump stations that are required, the storage capacity for the bulk reservoirs, head loss for each component, hydraulic profiles for pumping mains and pipe sizes, hydraulic profiles for the gravity mains, and evaluate of the need of pressure and surge control. Let's go to the step-by-step that I needed to follow in order for me to be able to design this project. So for step 1, I had to go and open my APANET. This is the finished design for the water system. So step 1, I had to first open here at project and go to defaults. This is where you go to hydraulics, and this is where you set the standards for the calculations, as well as the units for what you'll be doing here. So we know that since we have been given liters per second, so I've changed the flow units to LPS, which is liters per second, and we'll be using the HW formula in order to get the calculations right. The second step was to establish each of the points where they are in the drawing. So let's go here. as you can see here, as we set the default settings, and then we also almost forgot. Yeah, we also go to options, and you set your notations. You disable node IDs, display link IDs, and symbols. Everything must be ticked here. Right. Where am I? Right. As I said that the Nyangwa River will be used as the datum, and so will determine the reduced levels for each of the components of the system, as you can see here. These were then taken and inputted onto the components, on each of the components, as stated here in the screenshots. Very hectic. It's very important to be very careful when doing this step, not to input things in the wrong situation, in the wrong component. Yes, component, as this might affect your overall calculations and your overall output. Now step 3. Now for step 3, you see you then check your capture for your elevations if it's done. As you can see, it appears on this here screenshot. So step 2, it was determined from the levels that I've seen on from the levels that we will need 2 pumps, one in between the Nyangwa River and one in between Nyangwa River and Shikahilo water treatment plant, and one also in between Shikahilo treatment plant and the bulk reservoir. Using also those reduced levels, I also put in the heights. So the pumps will be pumping water from the river into the treatment plant, and then from the treatment plant to the, what is this? Let's just go to the big drawing. So the water will be pumped from the river into the Shikahilo treatment plant, then pumped again from the Shikahilo treatment plant to the bulk storage. After that, it will use gravity and will channel itself into the different demand centers. Sorry. Sorry. Where was I? Oh, yeah, we're in step 5. Water tank was provided at Shikahilo that will be used during treatment of water to carry water during the process of purification before transporting to the bulk water reserves, as I said. Step 6. The following settings are then applied to the APANET. As you can see, this is what I have already said before. And then if everything checks out, you can then go to your Ethernet and run the system, as you can see here. As you can see me doing here, go to projects, then you run the analysis. And as you can see here, the run was successful. If the run is not successful, maybe because of pressure, that's when you start you go back and look at your dimensions for your pipes, which I experienced, and I had to increase some of the pipes. So now for step 7, yeah, we also had to determine the diameter of our reservoir, which will be a tank, or which will be a cylinder shape with a height of 12.5 meters and a diameter of 34 meters. Using the basic formula of a volume, this is what you get for the area. You also take this answer into your Ethernet. As you can see from the screenshot. Right, after having a successful run, analysis was successful, you go into your pipe results for the following successful network analysis. So now it says here the following figures provide the 24-hour analysis of the network considering the demand ratios. The demand cycle runs for 72 hours, which is 3 days, and the pattern changes every 4 hours. The ratios are repeated every 24 hours. These are the results that I managed to get with these settings. Right. Here you get your length, which was the one that I already inputted for the pipes. You also get your diameters here, your roughness, which is also a setting that you also set up, and then the flows that you get on each pipe, which all meet the requirements. And you also get to run your softwares to get your base demand, your head loss, your head and your pressures, to get your head and your pressures. And this is the energy report. All of these you get them from your Ethernet, where you go to report. Get them from your Ethernet, go into report for energies. You get in here, and it tells you the type of energy that will be used during this process. And then for tables, come here, network links, if you want your nodes, if you want your links, which is your pipes, and then here it's already has the thing. So yeah, this is what you get. the type of results that you will get. So thank you very much. Thank you very much for giving me this opportunity. This has been my report, and this has been a very good learning experience for me. I'm hoping that this meets your satisfaction. Thank you.